Hey Algebra 1! Today's notes are about graphing linear inequalities. So last week we looked at how do we know if a point is a solution to an inequality and what does that look like on a graph. Today we're actually going to be graphing them. So we're going to start with this solve problem at the top. So this is just a word problem. And we're starting just by looking at what is this question asking us to find. So Shane is going to the movies with his friends. His mom gave them $15 for snacks. Drinks cost $2 each and candy costs $3 each. How many of each can Shane buy? So if we underline the question, what we're really looking for is the number of drinks and snacks that Shane can buy with $15. We are actually going to go through and write an equation, solve this, find the solutions, how many drinks and snacks he can buy next week in FlexBlock. So our notes for today are focusing on how do we graph these inequalities. And when we're graphing inequalities, the first thing that we have to do is plot the points that would make our line. So if we look at our first equation here, this says y is greater than x plus 1. For a second, we're just going to pretend this says y equals x plus 1. And we'll graph what that would look like. So if y is equal to x plus 1, that says I'm starting at positive 1 for my y-intercept. And my slope is 1 over 1. So it says I'm going up 1 and to the right 1 to make more points on this line. Now normally, once we had all of our points, we would connect them with a solid line. But that is not always the case when we're looking at an inequality. So now that I've got all of my points on here, I'm going to stop pretending this says y equals, and I'm going to look at the inequality symbol that's here. This one says y is greater than. So y is not equal to x plus 1, it's more than that. So in this case, we are going to decide if we have a solid line or a dashed line. So in any scenario where something could be equal to, where I have less than or equal to or greater than or equal to, I would draw a solid line on my graph because it could equal the things on that line. But in this case, where we just have less than or greater than, we make a dashed line on our graph. So instead of connecting all these points, I'm going to connect, some of them to show that my line isn't solid. It is a dashed line. So now that we've done that, we need to show that y has to be greater than all of those points on the line. And we saw that when we had a solution to an inequality, we had part of the graph was colored in to show that that's where all the solutions are. So if we have y is greater than or greater than or equal to, we shade above our line. And we would shade below the line if we had y is less than or less than or equal to. In this case, this says y is greater than. So we already know that that meant we're going to have a dashed line. And because it's greater than, I am shading above the line. So one easy way to think about this is that when I'm shading above, so I can draw arrows going up from my line. And that tells me the part of the graph I need to color in is this side right here. All of the points on this colored in part of the graph will show that our y value is greater than the x value plus 1. So anything above that line. Another way that I can determine which side of the graph I color in is to check a point. So we can check if 0, 0 is a solution. And on the graph, 0, 0 is right here. So when I substitute that x and y value into my equation, I am checking if that point works in my equality. So this would be 0 is greater than 0 plus 1. So this says 0 is greater than 1. That's not true. This is not a solution. So because 0, 0 is not a solution, the part of the graph that has that 0, 0 point can't be colored in. So that just confirms what we already knew. We have to shade above this line, not the part of the graph that has 0, 0. So these are the 3 steps that we'll follow every time. We'll plot the points on our line. We'll decide if our line should be solid or dashed. We'll decide if we're shading above the line or if we're shading below the line. So for our second example, our inequality says 2x minus y is greater than or equal to 4. My first step is to plot some points. But this equation is, nope, none of those are the right words. This inequality is not ready to be graphed. It doesn't look like y equals mx plus b. So the first thing I have to do here is change this inequality so that y is isolated and by itself. So the first step would be to subtract 2x on both sides. So now we have negative y is greater than or equal to negative 2x plus 4. So now I have negative y is greater than or equal to negative 2x plus 4. So this is almost y being isolated. The problem is there's an invisible negative 1 here. So every single piece of this inequality needs to be divided by negative 1. So now I'll have positive y. And if you think back to what we know about solving inequalities, if we divide by a negative number, our inequality symbol has to switch. So negative 2x divided by negative 1 is positive 2x. Positive 4 divided by negative 1 is negative 4. So now I'm finally ready to start plotting some points here. This says that my graph is starting at negative 4, and my slope is positive 2 over 1. So I'll rise 2 and go 1 to the right, and I'll keep making points on my graph until I run out of space. Once I run out of space, I go back to my starting point, and now I'm going down 2 and left 1. So that was step 1. We plotted all of our points. Step 2, we have to decide, is this a solid or a dashed line? Well, this says y is less than or equal to, so that's going to be a solid line. And because it says y is less than, we're going to be shading below the line for this one. So I can connect my points with a solid line. And if I'm shading below the line, well, I can draw, starting at my line, draw some points that are going down. That shows me that this side of the graph should be the side that gets shaded. I can confirm and double check that I've shaded the right part. So we can check, is this point 1, 2 a solution? So is this point on the graph 1, 2? Should that be in the shaded part of my graph, or should it be in the not shaded part? So I'll substitute my x and y value back into my equation. Back into my inequality. So I have 2 times 1 minus 2 is less than or equal to 4. Well, 2 times 1 is just 2. So is 2 minus 2 greater than or equal to 4? Well, no. 0 is definitely not greater than or equal to 4. So that is not a solution. So that tells me this green point should not be in the colored in part of my graph, which means I shaded that correctly. Our last example on this page says y is greater than positive 2. There's no x here at all. This is just a y only inequality. When that happens, this is going to be a horizontal line. Y has to be greater than 2. So where y is equal to 2, I'm going to make some points here for my horizontal line. And now I have to decide, is this a solid line or a dashed line? Well, in this case, because it's only greater than, not greater than or equal to, this is going to be a dashed line. And because it's greater than, we are going to shade above the line. So really, all this problem is saying is that the y values that are part of our solution have to be more than 2. They can't equal 2, they have to be more than that. So there's my dashed line. All of my y values that are greater than 2 exist up here, above my line. So, and for this one, we are checking this point 3, 2. 3, 2 is actually a point on the line. It would be right here. And we know because y has to be greater than 2, that point should not be a solution. But we can double check just in case. So if y is greater than 2, my y value that I'll substitute in is 2. And 2 is greater than 2 is not true, so that's not a solution. So these are the 3 steps we follow every time. Plot your points, decide if it's a solid line or a dashed line, decide if you're shading above the graph or below the graph. So on the next page, we are going to graph these inequalities and then answer some critical thinking questions about them. So my first one says x is greater than 3. Well, an x equals line is a vertical line, so I'm going to plot some points where x is 3. And now I need to decide, is this a solid line or a dashed line? Because this is just greater than and not greater than or equal to, this is going to be a dashed line. So let's fill that in here. And now this says x is greater than 3, and usually greater than means we're going to be shading above the line. But in this case, I don't really have an above the line. But if we just think about what this equality is saying, it's saying that x is bigger than 3. So I'm going to shade in the part of my graph that has x values that are greater than 3. And in this case, that would be over here. I could check a point if I wanted to. So let's check a point that I think is a solution. Let's check 9, 1. If I'm right, if I shaded the correct part of my graph, 9, 1 will be a solution. So my inequality says x is greater than 3. This x value I picked is 9. Is 9 greater than 3? Yeah, absolutely. So that is part of my solution. That side of my graph should be colored in. So now we're going to think about what differences would there be if our inequality symbol changed. So what would happen if we switched our inequality symbol to a less than? Well, if x had to be less than 3, then I'd be shading the other side of my graph. The next one asks, what differences would it be if it was still greater than, but now it was greater than or equal to? Well, that would mean I have to have a solid line because it could be equal to 3. Okay, last one we're going to do together. Y is less than or equal to 2x. And I know to graph this, I can add a plus 0 there to show that my y-intercept is at 0. My slope is positive 2, so I'm rising 2 and going 1 to the right. When I run out of space, I'm going to go backwards down 2, and left 1. And now I have to do the important parts. Is this going to be a solid line or a dashed line? Because it could be equal to, this is going to be a solid line. And it says it's less than, so I have to shade below the line. So I'm going to connect all my points for a solid line here. Because it is less than, I am shading below the line. And if I wanted to, I can check a point. I think that I should be shading this side of my graph. So let's check if 5, 2 is the solution. That's in the part that I shaded. Does this actually fit in my inequality? Well, my inequality says y is less than 2x. My y value that I chose is 2. X value is 5. Is 2 less than or equal to 2 times 5? Yeah, absolutely. That is a solution, which means I shaded in the correct part of my graph. The part of the graph with the point 5, 2 is colored in. So now let's think what would happen if our inequality changed. If we switched from less than or equal to greater than or equal to, well, now I'm going to be shading above the line instead of below it. And what would happen if we switched from less than or equal to just less than? Well, now I would have to have a dashed line because y cannot be equal to 2x. It has to be just less than that. So that's all of our notes. Your job is to finish the rest of these practice problems. So you've got a couple more questions like the 2 we just did. There are 3 questions here where you are graphing these. On example 2 and example 3, those equations are not set up and ready to graph, so you need to graph them first. And then on this last page, you are matching the inequalities to their graphs. So be careful here, 1 and 2 are also not ready to be graphed. So you might want to rearrange those so that they look like y equals mx plus b before you try and match them to their graphs.